All right, Sam Jarman. What what can I say about Sam to introduce him and commend him to you? Well, first of all, he is from New Zealand. What's up?
Woo!
Come on, all the Kiwis in the house. Where are you?
Just us, James.
Just us two? You laugh, but that's like what, 3-4% of the population?
That's right.
Something like
It's
that.
like,
Oh, look, Sam, honestly, known for a long time, has made me laugh more times than I can count. If you haven't seen his lightning talk from when?
which one?
The one.
All of them?
Well, I mean all of them, but the one in particular, right?
2018, 2019? 2018, I think.
Anyway, Australia, what's it called? Australia versus New Zealand.
A 100% fully serious bro comparison.
Yeah, look it up on YouTube. It is like if there was a Hall of Fame of Dev World Lightning Talks, that would be right at the top. You've got to go check it out. But so Sam came over the ditch to Australia, what, last year?
2 years ago now.
2 years ago, and
2020.
I spotted an opportunity. I snapped him up to come and work with me on some projects. It was amazing. Like I took him in, and I nurtured and cared for him, and
Yep.
and developed him, and poured my expertise and love and money on him. And then when it was time, I pushed him out from the nest and watched him soar like a beautiful, graceful eagle into his new role at Cochlear. Where he's been kicking goals ever. Kicking goals. That's like an Australian phrase for like it's like
Scoring
a
goals.
thing where you.
Is it that one or is it
No,
that one? Okay, yeah.
The big stick things. No,
4 sticks or the 2 sticks?
I joke. It's exactly the opposite. Like I've always had this policy of only employing people who are smarter than me, and Sam absolutely fits that bill. So seriously, I don't even know, frankly, what he's talking to us about today. But whatever it is, you are going to leave this room a different person, right? You are going to leave a changed person. So please, everyone, rise to your feet, please. Rise to your feet. And join me in giving a huge round of applause. Come on to your feet.
Oh, wow. Shit. The expectation, the expectation is high. Hi, everyone. I'm Sam. I'm going to be giving you an introduction to backend development today. I'm a dirty imposter. However, I feel it is my birthright to be here. I have been doing iOS since ages ago. Since 2009, I had a bunch of apps on the store before I left high school. Continued to work for agencies, banks, startups in the mobile space for quite some time. In 2019, I shook things up. I mean, the world shook things up. And I've been doing backend dev since then. Obviously, I'm very happy to be at Cochlear. I love that company. I think it's what it does is awesome. But the thoughts of today are my own, because of course they are. Let's get into it. You've probably seen this from time to time in iOS as a user, as a developer, and hopefully you've wondered what's going on the internet while I'm looking at this. So I'm going to explain what's going on the internet. This is a different sort of talk than what you might have seen. It's Sebastian's talk. This is not how to get started doing backend dev. This is how to get started at getting started. We are going to be nice and abstract. I want to kind of give you a mental model for what happens on the back end, so you can start for yourself, and I can bring my experience into learning all these things very manually and having to piece together this mental model and just give that to you today. So you'll be able to have a really nice head start. We're going to talk about what a backend developer is, and then we're going to talk about building an application and taking that all the way from hosting it, deploying it, exposing it to the public web, scaling it, and we'll spend a little bit of time on other types of applications in the back end, and then hopefully some time for questions. So there's no dumb questions. Ask me whatever you like. If you've heard of something and you don't know what it means, now's a great time to ask. By asking a question, you will benefit everyone in the room, not just yourself, so don't be shy. All right, so what is backend development? We know what iOS development is, but what's backend development? It is the job of storing and retrieving data in a way that's fast, scalable, secure, and reliable. That sounds really easy, but it's not. There's lots to it, and there's lots of different ways of doing it. But today we're going to talk about building an API. So, building your application. For this, you'll need a text editor. There's not much in the way of IDEs in the web space. There is WebStorm, but I like VS Code, Visual Studio Code. It's a cut-down version of Visual Studio. It's comparable to Sublime if you've used that. I like it. You don't have to use it. Use the one you like. you'll want a programming language to use. Now, you might want to use Swift. You can use Swift. You can use almost any programming language you can think of. And you'll need a web framework that's compatible with that language, or built in or on or for that language. I don't care which one, just choose one. Here's a couple of options. So you've probably heard of Vapor. We heard about it this morning. You've probably heard of Katura and Perfect as well. If you're out in the JavaScript ecosystem, there's a bunch there to be used. Ruby on Rails you've probably heard of. Don't know what it does. That's fine. You can use PHP, C#, Python, Java. I don't care. Just choose one. You'll see why it doesn't matter later. So at this point, you're like, whoa, slow down. What happened to the introduction stuff? What is a web framework? Let's talk about what a web framework is. So it is a bit of code that comes into your app as a package or a dependency. And at the start, when you launch it, it will go and talk to the operating system and register your code as the thing to be talked to when a request comes through to that computer on a certain port. So you may be aware that the internet generally runs on port 80 or port 443 for HTTPS and HTTP and HTTPS respectively. You can run your server on whatever port you like, but those are the standard ones. Then in this web framework, it allows you to define routes. Now, a route is the bit after the .com.au in the URL. So that can be /users, /ID. That includes the query parameters, the path parameters, all that sort of stuff. So you'll do that little bit of setup. And then on a request, you'll be able to run some code that you've written to do the response. So web frameworks are mostly the same. Now, this is a very controversial statement to people who are passionate about web frameworks. I'm not passionate about web frameworks, but I know how to use them. I'm abstracting a little bit here. There are differences in web servers, web frameworks, backend frameworks, but generally they're just called web frameworks. Some do very little. Some do what I just described. They give you a little entry point to responding to network requests. Some do the whole thing. They talk about and mandate a structure for your code all the way from request to database and back again. Some of these frameworks offer those opinions. Some of them force those opinions, and you can decide if that's something that you like in a web framework. So just find one you like, learn it well, and then use it. So here is an example of a web framework. This is Vapor. I thought I'd start with Swift to test the waters. In here, we have a reference to the application called app on line 11. There is a function on app called get, and that represents like a get request. There's a function called post and put and options and head. And then the URL there is users/ID. At that point, you're given the request, and you can grab out things from the request, like the query and the path parameter. So I've got a query here called include loyalty, and I've got a path parameter for the ID of the user. So once you've gotten all your stuff out of the request, it's up to you. You go from there. So I'm loading and using this very real database code to load a user from the database. Here is the same code in Fastify. So here we have a reference to the app called app. There's a method on app called get. Now this represents a URL called user/ID. Here you're given the request, and you can see where I'm going with this? You can grab out the request parameters, the path parameters, and load the user from the database in my very real database code. They are very similar. They are very similar. Look how similar they are, Tim. They are just so similar. This is why I'm saying it doesn't matter. They're all inspired by each other. They've all taken the best things, and it's just gone around and around circles. Everyone's had a great sharing time. They all look very similar to the day for the sort of stuff you'll want to do as you're starting out as a backend developer. So yeah, any web framework will do. Just choose one. I don't care. Now, hosting your application. There's different ways of hosting your applications. As you've done your backend dev or any experimentation you've done, you might recognize one of these methods. Jump on the train at that point, and I'll bring you to the more modern techniques towards the end. So the first one is having just a machine or a virtual machine. Now you might want to have your Mac. You might have a Mac Mini in a cupboard. You might have a Raspberry Pi, or you might go pay a hosting provider to give you a virtual machine. That could be Amazon, Azure, Cloudflare, DigitalOcean, any of those sorts of companies. If you get a virtual machine or a physical machine, the minimum you'll have is SSH access. So you're able to SSH into it, install stuff, and install your application, install its dependencies, start it running, and then it's able to start answering the quest, just like it was when you were developing it. You might also want to make it restart on a fresh boot, because too often when you set stuff up like this, the first time you unplug your Raspberry Pi because you're rearranging your office, doesn't restart and your little personal project's gone down. You never get back to it. Yeah, So the next one is app hosting services. So generally speaking, these sorts of companies like Elastic Beanstalk, App Service, App Engine, Heroku, they recognize that you're using a popular web framework. They can spot the package.json file or the package.swift file and go, oh yeah, okay, I know how to install the dependencies in this project. I know how to run it. All good. So they will take your code from your Git, from your GitHub or your Git remote, and just run it for you. And it's really quite straightforward. The next one is Docker. Now, everyone's heard of Docker. We heard a little bit about it this morning in Seb's talk. It's very, very confusing. It has a steep learning curve, but I'm going to try to simplify it a little bit today. You create a Docker file. Now, a Docker file is the bridge between the Docker runtime and your application. The Docker runtime knows how to run Docker files. The Docker files know how to run your application, and through the transitive property of knowing how to run things, the environment runs your application. So if it works on your machine when you run the Docker locally, you will guarantee that it will work properly, well, mostly guaranteed that it will work properly on the server. So here is the Docker file you get when you do a new Vapor project by default. Here's a smaller one. So this is Python, for example. So you can start from a base image to declare your virtual machine. This one's Ubuntu. We know what Ubuntu is. It's a Linux distro. You copy over your files to it. You run make against the app. That will probably do like a pip install, that sort of stuff. And then you just run Python against the Python file or Swift against the Swift file or whatever it takes to invoke your application. That's sort of the minimum you need. Obviously, you can geek out a bit with build images and deployment images and make them thin and small, but that's kind of the main idea. You use these blue words on the left to do certain actions, and then the runtime knows what those blue words mean. So it's quite straightforward. There's a couple of different ways to run Docker images or Docker containers. The first way is proprietary image runners, and these are kind of built up by the big boys in the cloud hosting space. Amazon has Elastic Container Service, or ECS, and Azure has Container Apps. So you can put your code there, and they'll run those. Kubernetes is something you might have heard of. It's a more popular open source, I think originally span out of Google, way of running containers in a nice sort of cluster of containers. Now, Amazon supports this in their Elastic Kubernetes service, so there is a bit of redundancy there between Kubernetes and container service, but that's fine, as well as Azure's Kubernetes service as well. Generally speaking, use one of these two methods. You don't want to really be running your own Docker cluster yourself. You'll lose the point of it. Serverless. We've heard of serverless a little bit this morning, and I'm sure you've heard it before, but what on earth is serverless? First of all, it's a terrible name for what it is. This joke is bandied about. It's hard to credit, but calling serverless is like getting pizza, calling it kitchenless. Yes, there is a kitchen somewhere, it's just not in your house. There is a server somewhere, it's just not something you need to think about. So yeah, we just call it Lambda. So in serverless, you deploy functions to the cloud, not applications. And your function is invoked when a request comes in, and you're given everything you need to understand the request and respond. So there's no web framework. The system of API Gateway and Lambda, for example, is the web framework. The function is that route handler. So an example of this in really simple TypeScript is you have your event. Your event has the headers on it, the path parameters, the query parameters. You can do stuff, and then you can return objects or JSON or strings or whatever you want to just return. And that's your route handled. You make one of these little functions per route. So lots of serverless providers. Obviously, Amazon pioneered this space about 9 years ago with Lambda. It's very cool. I'm a member of the Church of Lambda. Azure has Azure Functions. Cloudflare has its Worker product, and Google Cloud Functions as well. And there's a bunch more popping up. Other companies are starting to offer them, and sometimes they're built on the ones above in that list. So, hosting advice for this sort of stuff. Do it yourself for simple stuff. So if you're doing little tiny projects or you want it entirely within your home network, Raspberry Pi or a Mac Mini is totally fine. Then you can want to start using a hosting provider for sort of anything else. And there's kind of what I call serious ones and then enterprise ones. So serious is like Cloudflare, DigitalOcean, Linode, a bit cheaper, a bit more control, a bit more reliable than a Mac Mini in a cupboard. And then you go to the sort of the enterprise ones, AWS or Azure. You can use AWS and Azure immediately if you want. There's just more of a learning curve that you might not be in the mood for. With the enterprise ones, AWS and Azure, those are the big guys. There's a lot of safety in numbers there, and we like safety in numbers in the back-end world where there's a lot of ways of doing things. That brings you really good communities, good GitHub issues, good support. You're not the first one doing the thing you're trying to do, almost ever. There's good SDKs for popular programming languages, that sort of stuff, as well as a presence here in Sydney and Melbourne. So, pros and cons in brief. Now, each of the boxes in this table is probably a talk of its own, but so to compare them in brief, sort of VM or a Raspberry Pi, you have full control. It's very cheap to get started, but it's very manual. You're setting up everything. You don't get anything for free, so to speak. App hosting services, very easy, very cheap, but you get minimum control. They'll run your application, hopefully it works. So it's kind of sometimes a bit guess and check on how it's going to do stuff that you want it to do. Docker, obviously you have full control with that sort of stuff. There's a big ecosystem around it. It is cloud agnostic, but there's a stupidly steep learning curve for Docker, which I'm not even convinced I'm at the top of. So keep going. And then serverless, easy and cheap, but big projects become hard to manage once you get, applications that are a collection of many, many lambdas. They take longer to deploy, longer to debug, that sort of stuff. So let's talk more about deploying. Deploying your application is tightly coupled to the way you're building your application, or where you want to host it. So we'll talk about the different ways of hosting. So in the VM Pi space, you can just copy the files over. SSH in the server, or secure copy them over, FTP upload them, or even try to get clever and check them out with Git on the server. This is a valid method and it still works today. And at that point, you need to restart your application, so it'll pick up the changes to the files. And then once you've restarted your application, your code's deployed, done. Obviously, this feels a bit hacky, and we like to automate that more in modern times. You can use Git to deploy. So the app hosting services, they'll give you either a Git repo, or they'll get you to connect to your GitHub. So you kind of push to master, and that triggers the deployment phase, and they take it from there. They'll just deploy the latest code in that commit. Really quite straightforward. Docker images. So with Docker, we talked about that Docker file, that when it gets baked, it gets turned into something called an image. And you put those images in an image registry, which is just basically a big bucket of files. You typically name them by the semantic version of the application, like 1.0.0, 1.1, 0.1. And then you tell Kubernetes or ECS or EKS to say, okay, go use that image. So when you want to do a deploy, you want to create your new image that's typically got a reference to the latest code. You want to give it a unique name different to the previous image. You want to push that up into your registry. And then when you're ready and it's finished and pushed into the registry, you then tell your cluster to say, hey, stop using that version and start using this version. And so it'll pull down that image from the registry and start the application running. And you might have like a special URL on your application called like /health. If that responds with like a 200, it means your application's properly started. So it'll wait till that succeeds, and then it'll kill off the old one. So you get this kind of seamless transition from old code to new code without any downtime, and you'll guarantee that the new thing you deployed will actually work most of the time. It's a bit more tricky, but a lot of the stuff can be done with your CI/CD pipeline as well, which we don't have time to talk about today. Cool. Serverless is a bit more tricky. Generally, you're pushing a zipped code into like an S3 bucket for Lambda to pull from, or some sort of storage location. There's a very popular framework called serverless.com, which is sort of like a competitor to AWS SAM we heard this morning. I don't like AWS SAM because I get confused if people are talking to me or not. That's fine. Serverless.com is actually really, really good. You write your code and it generates all the infrastructure as code needed to push that up into the cloud for you. So you kind of write your code, you write serverless deploy, job done, or SAM deploy, and job done. Now, this infrastructure of code has been bandied around a little bit this morning. I want to talk to you more about it. There is a whole world in backend development where you can write your infrastructure as code. And what we mean by infrastructure is like, instead of going to the AWS portal and clicking next, 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 finish, for the 100 things you might need to build your suite of software, you can say, I want this, I want this, I want this, I want this, go, and it will do it for you. So it's like a declarative code. It looks like SwiftUI a little bit, and it can generally access, depending on the product, access anything inside of AWS or anything inside of Azure or Google Cloud, and it's quite all right. The big boy in this one is AWS CloudFormation. It sort of was the pioneer of this area. It is not perfect, unfortunately, and there's quite a lot of ways where it gets confused and just refuses to do stuff. So that spawned an open source movement from a company called HashiCorp, and they've created something called Terraform. And Terraform is another declarative programming language which supports multiple clouds, and it's much easier to use and has better detection when you're changing stuff manually versus not, and generally just doesn't fall over and fail as much, and subsequently is becoming the leader in the space of infrastructure as code. Here's some examples of infrastructure as code. On the left, we have CloudFormation, written in a language called YAML, which is like you want to write JSON, but you want your life to be harder. So here we have a bucket, which is the type of resource creating. S3 bucket is like just a file storage product, giving it a name and giving it some arbitrary tags there. On the right-hand side is the same code in Terraform, once again creating an S3 bucket, giving it the name migrate bucket, putting some tags on it. This is in a language like called HCL, or HashiCorp language, and it looks like JSON, but it's got ruined a little bit. You'll figure it out. Very easy to read, slightly trickier to write. You can write CloudFormation in JSON, it's just not really a done thing. Exposing your application. So you've built your application, it's up in your hosting provider, but unless all the people using your apps want to come and join the VPN, they're not going to be able to access it. So we need to make it public, and we probably want to give it a nice, pretty URL in front of it. So this is something that no one struggles with. You just buy a domain name, set up DNS, and you're good. No, people struggle with this all the time. DNS is a fucking annoying technology. It's essential, and it's hard because, not that it's complex or confusing, it's hard because of its very slow debug loop. The time you make a change to DNS and the time you find out that you're wrong or right with 100% confidence is variable between like 20 minutes and 24 hours. When you make a change to DNS, it needs to go and update all the computers over the world that agree that samjarman.co.nz means 123.123.1.1. It makes sense for DNS, but other systems built on the same things are also quite slow. Bitcoin. So let me simplify DNS a little bit for you. So first of all, you want to go buy a domain name. And you do this through a type of company called a domain name registrar or registry. I recommend iwantmyname.com. It's a New Zealand company. Let's support some cool companies down this end of the world. Probably the first time and only time I mention a company founded in this part of the world in a cloud talk. It has a very cool interface for searching domain names. You type in the domain name you want, it'll give you every possible top-level domain name extension like .com, .au, etc. So you buy that, they're roughly $20 a year. You log into that website, you then get access to the DNS settings. Then you go back to your hosting thing that you set up with, and they'll either give you a record, like an IP address, so 123.123.1.1, or they'll give you like a domain name. And if it's like AWS, they'll typically give you a domain name. They'll have AWS somewhere in the URL. So if you get given an address, use an A record. If you get given a domain name, use a CNAME record. Then wait like 20 minutes and see how that works. Now there's tons of tutorials from both sides telling you how to do this. You just want to marry up the two tutorials in your head, looking for how do I get the IP address or the domain name, how do I put in the A record or the CNAME on that side, and just click them together. Some domain name registrars have automatic setup for this sort of stuff as well. They know how AWS works or Squarespace or anything like that, and they'll just click together with a few key bits of information from you. So don't stress out too much about DNS. It does make sense. It just takes ages to know if you're right, which sucks. So for HTTP and SSL, just go. This used to be a $200 or $300 exercise to go get a certificate, get it signed. It's a real pain in the butt. Just go to let'sencrypt.org. It'll walk you through how to get one. They're free now. So the padlock sort of means nothing anymore. They're like the blue check on Twitter. They just don't have that same meaning of secure anymore. It just means you got a free certificate. It does mean your traffic is encrypted from your phone to the web, or from the browser to the web. But yeah, it's not the advice it used to be. Cool. So scaling your application. You've built it. You put it on the back end. You've done your iPhone coding to connect to it. You put it on the App Store, and then John Gruber tweets about it, and now it's got like 1 million users. So what do you do then? So there's some techniques I want to cover today. There's two types of scaling. Now, we've all heard of scaling. That is the idea of responding to more request traffic. There's two types. Vertical scaling. So vertical scaling is about making the computer that's running your web application more gruntier, giving it more RAM, more CPU, more GPU, more disk. That typically is a slow process. You want to either shut down that computer and spin up a stronger one, or spin up a stronger one and then do like a little switch thing. And it's not something that's terribly easy to do or easy to automate. So there's another technique called horizontal scaling. That's when you go out sideways and you just add more computers of the same type. You have one computer all set up with the right amount of RAM and CPU. Your hosting provider can just copy that and make 2 of them, 3 of them, 4 of them, 10 of them, 100 of them, 1,000 of them. And that can do it really quickly. The best thing about this is automatable. You can do things like, if the computer that's running your application is at like 90% CPU, you can go, oh, that's too high, let me spin up another computer, and now they'll both be at 45% CPU, roughly. And then if the traffic goes away and they're both down to like 10% CPU, oh, I'm paying for too many computers now, and you can go back to 1, and it kind of hovers at around 20% CPU. You can do that with memory, CPU, the amount of network traffic, disk usage, GPU usage. Any sort of statistic about the computer you want to trigger that on, you can generally trigger that on. Often this is done for you. Those app hosting places I was talking about, like Beanstalk, Heroku, they'll just start to scale for you. They'll monitor CPU and memory for you, but you can set it up with Kubernetes or a container service on your own reasonably easy. Now, serverless is a special case here. Serverless is horizontally scaled by default. If a request comes in and it boots up your Lambda, and your Lambda is dealing with that, and a second one comes in, it might boot up a second Lambda, and it can do that for about 1,000 Lambdas. But generally speaking, you won't need 1,000. But to serverless, you just deploy the function, and scaling is taken care of for you. And now you're probably wondering, in my head, I have a domain name to an IP address to a computer that's somewhere in a rack at Amazon. Now I have 2 computers. How does that work? It's a great question. This is done by a process called load balancing. So what will actually be happening is you're not giving the IP address of a computer or a common name of a computer. You'll be giving it to a special program that runs called a load balancer, or an application load balancer. So that will have the IP address instead. So everything comes to this central point called a load balancer. These things are run by Amazon or Azure. They're fast as heck. They won't go away. They know what they're doing. That thing is aware of all the computers available to it to answer requests. So as a request comes in, say request number 1 comes in, that will go to computer number 1, 2, 3, back to 1 again, 4, 5, 6, and they'll just go in a round robin pattern and just distribute the load evenly across the machines. And as scaling events has happened, that the ALB gets told about that, or the ALB is doing it itself, and it knows about its compute pool shrinking and growing and how to distribute the requests again. This is fantastic and works really well, and there'll be basically every app you'd use that is significantly popular will be using this technique. It does mean as a programmer, you have a weird limitation that you're not used to in iOS. You cannot put things in memory. Well, you can, but you shouldn't. There's no guarantee that the computer that answered request 1 from the same user is the same computer that answered request 2 from that user. So if request 1 is a login and request 2 is a request for the person's Mastodon timeline, you might not have, if you put the login credentials or the login check in memory, you have to start that process again. So that's the point. You want to use a database or a cache, something central that is not on the computer answering the request, which makes things trickier, takes things longer, but it means you can scale out. So, well done. You're a backend dev. Those are the big concepts to know. Now, time to go on a bit more of an abstract, generalizing some high ideas. Everything is an event in the cloud. In an API world, the API request is an event, okay? Now, everything starts an event, and things can send more events, and this is the same in iOS as well, right? We know about application did finish launching, UI touch, gestures, push notifications arriving, the phone shaking, all those sorts of things trigger some sort of code. And part of the job of being an iOS developer is knowing which trigger to find to start that process. And the same thing is in the cloud, right? Network requests are just one type of trigger we respond to in the cloud. We actually do a lot of programming on various different requests all the time. It's the same as saying iOS programming is not just about handling button touches. There's more to it. Same thing in the cloud. There's more than just APIs. We react to things like database entries changing, files being modified inside of file storage areas, time-based triggers, something happening every day or every hour, messages appearing on queues. There's probably 50 to 100 types of events you can subscribe to in the AWS ecosystem. and we probably use 5 to 10 on a day-to-day basis when we're just thinking through stuff. There's heaps. So that was my aha moment in the cloud, and that's something that hopefully you can see the parallels from iOS programming to cloud programming. There's not many other apart from that. There's a bunch of stuff I didn't have time for today. In a 25-minute talk about the cloud, you're just not going to achieve it. So I've tried to keep it quite high level. Some of the things I do want to cover quickly is these things. So performance and monitoring. As a backend developer, and one of the things I miss the most about leaving iOS to go to the backend is that we don't have a huge impact on the experience of the user. We're not the ones to decide button colors. We're not the ones to make cool transitions between view controllers. But what we do get to do is make things fast. And fastness and speed is our impact on user experience. How long is someone waiting for a message to download? How long is someone waiting for a tweet to send? That sort of stuff is the things we get to control. And it's one of the most fun part of the jobs. Database technologies, something I'm not going to cover today. There are different databases. Learn about them, choose one that will suit you. There's heaps of advice on what to do. Now, I've missed security, and most people do. Sorry, Lewis, wherever you are, Lou. But he's talking about it next talk, so just hang around. That also ties into authentication and authorization. Authentication being who are you, and authorization being what do you want to do. They're two different questions with two different answers. CI/CD, obviously pipelines, that sort of stuff, different ways to do it. I'm sure you've used a CI/CD pipeline at the moment. They're roughly all the same. Choose one, learn it, use it. Pricing and costs. Look, Amazon's not a charity by any means. They won't give you computing costs completely for free. They'll give you a lot for free, so will Azure, but they will end up asking you for some money to run the computers you're using. And there's a whole school of learning around optimizing those costs, monitoring those costs, predicting those costs, and making them generally smaller. And Amazon is surprisingly, and Azure, helpful with helping you pay them less. There's things like knowledge certificates. Both Microsoft and Amazon offer certificates to say that I'm a good cloud programmer, and they have their merits, and different people view them differently. So they're also worth looking into. API design I didn't want to cover today because I'm sure you've used APIs and have firm opinions on what good APIs are and bad APIs. And then finally, if you don't like me and hate everything I say and don't like backend developers and never want to see one, there is a category of products called backends as a service. And that's like Pars, Superbase, Firebase. Amazon has Amplify. There's also one called Couchbase. Stay far away from Couchbase. I can't tell you that enough. These things will just let you get and set objects in the cloud. They'll handle conflict resolution for you. There's no need for a backend programmer. And that may be a viable solution to get a backend for your app. If you ever think you're going to get backend developers, tying your app's data model to your server-side code data model then becomes a massive violation of the law of Demeter, where you're starting to reason about each other's privates, which is going to make things harder to change and harder to maintain. So backends as a service, asterisks, carefully. Look, there's a lot to this. There's so much more than I can cover in 20 minutes. There's just so much in backend programming. That's sort of the reason why I left iOS to go to backend programming. I found myself doing the same thing every day, getting JSON from the server, putting it in a table view, ticket done. Getting JSON from the server, putting it in a table view, ticket done. If you're feeling like that, maybe be inspired by my path. Give backend programming a go. There is millions of ways to do everything, and that's fun, and it's great for people like me who are curious. It does suck to change jobs as a backend programmer, because you're probably not going to be able to take any of your knowledge from one company to another as easy as you would be from an iOS. It's like, you guys using Swift? You guys using Swift? Yes, cool. I'll work here. Whereas like you could move from TypeScript stack to a Java stack to a Ruby stack to a C# stack, change between clouds, change between deployment technologies, CI pipelines. The combinations and permutations of tools is just amazingly vast, and that's kind of why I love it, because I don't want to stop learning, and you can't stop learning a backend programming as well. That's me. Any questions? No such thing as a dumb question.
Well, let's start with a big hand.
Thank you.
It was like everything you've tried to teach me the last couple of years.
Yeah.
In a block. Yeah, questions. I'm sure there are some. Or are you all like, no, that's it. We're back-end developers now. We're all good.
Yeah, that was a really awesome, informative talk that gave a really good overview of everything that's required. I was just wondering, from the perspective of someone just wanting to start out and do something really simple, is there any kind of cookbook or a tutorial you'd recommend just to quickly bootstrap someone that's, say, building a quick iOS and just wants to spin up a really simple backend that they can start hitting and working against?
Yeah, it's a good question. I think the app hosting services is probably the easiest one, like Heroku or Elastic Beanstalk on AWS, or even some of the Lambda stuff that Seb was showing this morning. There's just not a quick way to do a lot of stuff. You will have to reason about a lot more than you think you will. But at that point, then you start looking for shortcuts. So you might want to use Swift. So you don't want to learn new programming languages. You're trying to do this. So there's heaps of Swift options. If you know other programming languages, you might want to use those instead. If you have a computer that is spare in your house, that is a good way to practice with a Raspberry Pi or an old PC or something like that. So yeah, there's no short answer here, unfortunately, apart from like backends as a service where you don't write any backend. But hopefully I've given you some advice on how to solve the sub problems and how they all fit together. Yeah, cool, thank you.
Hey, thanks for the talk. What was the steepest learning curve from switching from iOS to backend?
I think it would be Docker. I had to like relearn Docker 3 or 4 times. It makes a lot of sense to me now, but I'm outside out the other end of the tunnel. But yeah, it just didn't really make a lot of sense to start with, and I had to relearn the terms over and over again as well. The difference between an image, a service, and a container still kind of elude me, but I sort of know what I'm doing. I think after that, it was kind of the whole DNS. How do I actually I understand how to run a Vapor project on my laptop, but how do I get it to the world? That's what I've tried to tell you today. But also that was there's just so many little sub problems to solve along the way, and no one's, in my mind, tied them all together until today. Kind of arrogant, but that's what I was trying to do. Yeah, I think the TypeScript came easily to me. The web framework came easily to me. The use of databases came reasonably easy to me, and the trade-offs between them came easily to me. But it's just the infrastructure part that was being tricky. The one thing I'm currently trying to get better at is the infrastructure as code piece. I showed you those examples. I think we can all read that, but writing it from scratch is quite tricky. I've always been a fan of the automation engineer, the DevOpsy kind of person. I like what they do. I think it's fascinating, but it's just something I haven't enough time for to get into. But I think there's quite a lot to learn there too.
And last one.
Thanks, Sam. So I was wondering, we've talked about, hosting providers and deployment investments and things. Is there sort of a sweet spot where we have a limited need for migration, reasonable cost and security, and both to get started without the need to migrate or scale up too much? Where would you start?
I would, if I could see a future where my app was wildly successful, either a personal project or a work project, I'd probably just start in AWS or Azure and just eat the learning cost up front. There are hundreds of services and buttons on the AWS dashboard, and it's very overwhelming as to what they all do. And until recently, it was quite an ugly dashboard as well. It's gotten real good lately. It makes more sense now. Because as we said, we heard earlier from Seb, there's you get 1 million invocations of a Lambda for free a month. And that'll suit most people, especially dev and staging environments at a workplace as well. So you can go quite a long time on some of these big boy providers before your credit card even starts to get any activity. If you start in a smaller scale, then you'll need to do a migration later on. So it's whether or not you want to eat that upfront cost of the learning involved. But from there, AWS and Azure, and I wouldn't use Google Cloud because Google likes to shut down things, to scale with you. And they'll help you as well. Cool, are we out of time?
All right, that's all we've got time for. But if you have more questions, you can find Sam sometime the rest of the day. You can ask your question. You can bask in his majestic presence and admire him for the God among us that he is, right for the rest of the day. Right?
Thanks, James.
Yeah. So another big hand for Sam.